A modern engineer could not build it more perfectly today. The Great Pyramid of Giza stands as the single most precise structure from the ancient world, a monument of stone that holds mathematical secrets modern science is still unraveling. By the end of this, you will see this familiar wonder in a completely new light, understanding the specific, baffling accuracies that make it an eternal puzzle. How did its builders align it to true north with near-perfect accuracy, and why do its proportions seem to mirror the very shape of our planet? What does this tell us about the forgotten knowledge of a civilization lost to time? What does true human genius look like when it is carved in stone for thousands of years? That level of perfection was not a happy accident. To understand why it is so startling, you must first grasp the conditions under which this mountain of stone was born. The Giza Plateau, more than 4,500 years ago, was a landscape of raw ambition. The air was thick with dust and the sounds of labor, a symphony of chisels on limestone, and the immense, groaning effort of moving the impossible. This was a world without iron, without the wheel for transport, without the complex pulley systems we take for granted. Every tool was copper or stone, every muscle was human or animal, and every block of stone weighed as much as a family car. The project, intended as the final resting place for the pharaoh Khufu, was the single largest construction effort the world had ever seen, yet the goal was not merely size. It was perfection on a scale that defies belief. Consider the foundation, the very first thing these ancient workers had to get right. The pyramid sits on a base covering 13 acres. That is roughly the area of 7 American football fields laid side by side. Across this entire sprawling expanse, the builders leveled the bedrock to a tolerance of less than 1 inch. Modern engineers like Marcus Schultz have pointed out that this is a precision we would expect from a high-end concrete foundation today, not from a stone slab prepared with primitive tools over 4 millennia ago. How do you achieve such flawless flatness across an area that vast, using only simple sighting tools and water levels? This foundational feat forces a profound question. We have long told ourselves a story about the pyramid's construction, one of brute force and endless manpower. But what if the real story is one of breathtakingly sophisticated knowledge, of a geometry and a metrology so advanced that we are only now beginning to recognize its fingerprints in the stone? The mystery begins not with the pyramid's peak, but with this perfectly level plane upon which it all rests, a silent testament to a skill we have yet to fully comprehend. Standing at the base of the Great Pyramid today, you are struck by a quiet, almost unsettling sense of order. The structure does not simply rise from the earth, it asserts a fundamental relationship with the cosmos. Its 4 sides are oriented with near-perfect alignment to the 4 cardinal directions, north, south, east, and west. This is not a rough approximation. Modern surveys reveal that the pyramid's north-south axis is misaligned by a mere 3/60ths of a single degree. To put that into perspective, that is less than the width of a human thumb held at arm's length across a football field. It is an error so incredibly small that some researchers argue it could be accounted for by the gradual drift of continental plates or a tiny shift in the Earth's rotational pole over the last 45 centuries. In practical terms, for its builders to achieve this, the pyramid is essentially perfect. This presents our first concrete enigma. The magnetic compass would not be invented for another 2,000 years. So how did a Bronze Age society, working with copper tools and rope, establish true geographic north with such breathtaking accuracy? The answer lies not in the dirt at their feet, but in the night sky above them. Historians and astronomers suggest the method likely involved meticulous, long-term observations of the circumpolar stars, those stars that never set below the horizon, but instead appear to rotate around the celestial North Pole. By tracking the rising and setting points of a specific star, or perhaps using a pair of stars to bisect the true pole position, ancient surveyors could have fixed an immovable line on the landscape. This was not simple stargazing. It was a sophisticated, repeatable astronomical technique requiring deep patience and profound understanding. It implies a priesthood or class of scholar engineers who viewed the heavens as a precise, mechanical clockwork to be decoded. This celestial alignment is the first major clue that the pyramid's design was deeply intentional, a monument anchored as much to the sky as to the sand. But why go to such extraordinary lengths for directional precision? The reason may be far grander than ritual alone. This flawless orientation hints at a world view where the pyramid was a microcosm, a scaled-down model of order reflecting a larger cosmic truth. To see that truth, we must look beyond the stars it pointed to and toward the planet it was built upon. This celestial alignment was a declaration of cosmic order, but the pyramid's mathematical secrets run far deeper than its orientation. If you take the distance all the way around the base of the Great Pyramid, its full perimeter, and divide it by twice its original height, you arrive at a number that should not be there. The result is approximately 3.1415. This is pi, the fundamental constant that defines the relationship between a circle's circumference and its diameter. It is a transcendental number, one that ancient Egyptian texts, as far as we know, never explicitly defined with such precision. Their mathematical documents show practical approximations, but nothing that suggests they conceptualized pi as a pure, abstract constant. Yet here it is, seemingly encoded into the very fabric of a square-based structure. How is this possible, and was it intentional? One compelling theory comes from the 19th century researcher John Taylor. He proposed that the builders might have used a specific rolling measuring wheel, a unit of length that, when rolled in a complete revolution, defined a standard measurement. If the diameter of that wheel was 1 unit, then its circumference would naturally be pi units. By using this wheel to lay out the pyramid's base dimensions, they would have inadvertently, or perhaps very deliberately, baked the ratio of pi into the structure's proportions. This is more than a curious coincidence. It suggests the builders possessed a sophisticated, almost intuitive, geometric understanding of circles and their properties, allowing them to translate a circular relationship into a square monument. The pyramid, in this light, becomes a brilliant fusion of shapes, a square plan expressing a circular principle. This discovery shifts our entire perspective. It moves us from seeing the pyramid as a mere tomb to understanding it as a geometric treatise in stone, a permanent record of advanced knowledge. And if the architects were skilled enough to embed pi, a number representing infinite perfection, then it logically follows they might have incorporated another celebrated principle of harmony and proportion, one that would later captivate thinkers from Euclid to Leonardo da Vinci. The presence of pi was a profound geometric signature, but the pyramid's architects may have encoded an even more famous principle of harmony. Look at the silhouette of the Great Pyramid, its elegant triangular face rising from the desert. The ratio of its slant height, the distance from the tip straight down the center of a face to the midpoint of the base edge, compared to half the length of its base, produces a number very close to 1.618. This is the golden ratio, often symbolized by the Greek letter phi. It is an irrational number, like pi, that appears with uncanny frequency in patterns we find beautiful, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. In art and architecture, from the Parthenon in Athens to works by Leonardo da Vinci, this ratio has been consciously used to create a sense of natural, pleasing proportion. The suggestion that the Great Pyramid embodies this ratio centuries before the Greeks formalized its study is a point of lively debate among scholars. Some argue it could be a mathematical coincidence arising from the chosen slope angle. Yet, the closeness of the fit is compelling. If intentional, it transforms our understanding of the pyramid's design philosophy. It was not just about stability or size, it was about embedding a universal code of aesthetic and structural harmony into stone. This pursuit of an ideal proportion hints at a symbolic purpose far beyond a royal tomb. It suggests the pyramid was conceived as a perfect geometric form, a representation of cosmic order and balance meant to last for eternity. This idea of the pyramid as a model of perfection leads us to its most staggering implication of all, a connection not just to abstract mathematics, but to the physical dimensions of our world itself. The pursuit of perfect proportion leads to the pyramid's most staggering implication. Beyond mirroring abstract mathematical constants, the structure's dimensions appear to whisper a secret about the very planet it stands upon. There is an astonishing claim, one that moves from geometry into the realm of global science, that the Great Pyramid might function as a scale model of the Northern Hemisphere itself. The numbers are startlingly precise. Take the pyramid's original perimeter, the distance around its four sides. When you multiply that figure by the number 43,200, you get a result remarkably close to the Earth's equatorial circumference. This is not a loose approximation. The ratio of 1 to 43,200 is exact. This same scaling factor appears in another profound correlation. Multiply the pyramid's original height by that same number, 43,200, and the result aligns closely with the Earth's polar radius. This is not a single, curious coincidence. It is a double correlation involving two different fundamental measurements of our planet, both tied to the same elegant scaling number. Researchers and engineers like author Christopher Dunn have explored these correlations in depth, proposing the pyramid could be a geodetic monument, a permanent record of the Earth's size and shape carved in stone. To understand the weight of this idea, consider what 43,200 represents. It is not a random figure, it is a precessional number relating to the slow 26,000-year wobble of the Earth's axis. Dividing that great cycle by the 360 degrees of a circle gives you 72 years per degree of shift, and 72 multiplied by 600, another culturally significant number in ancient metrology, gives you 43,200. This suggests the builders may have been encoding celestial time alongside terrestrial space, weaving astronomy and geodesy into a single, unified model. If this was intentional, the implications are profound. It means that over 4,500 years ago, a civilization supposedly working with simple tools possessed a sophisticated understanding of the Earth as a spherical body and knew its dimensions with an accuracy that would not be matched in the West until the 17th or 18th centuries. How could this knowledge exist, and more importantly, how could it be so precisely translated into a mountain of limestone and granite? The tools to measure a continent or calculate a planetary circumference seem impossibly advanced for the era. This forces a difficult but fascinating question. Were the pyramid's architects working from a lost repository of knowledge, a legacy of observation and calculation passed down from a much earlier, unknown age? The search for an answer leads us away from the grand scale of the Earth and back to the intimate, physical details of the pyramid's own construction, to the stones themselves and the impossible tolerances with which they were placed. The scale of the pyramid's design is matched only by the sheer physical audacity of its construction. To translate those perfect mathematical ratios into reality required moving mountains. The final structure contains well over 2 million individual blocks of limestone and granite. Each one, on average, weighed as much as a modern SUV, around 2.5 tons. And that was just the common stone. Within the heart of the pyramid, in the chambers built to withstand eternity, the architects used granite monoliths of almost incomprehensible weight. The massive beams above the king's chamber, for instance, each weigh upwards of 80 tons. That is the equivalent of a fully loaded commercial jetliner, lifted to a height of nearly 200 feet and slid into place with micrometer precision. The logistics of this operation, even with today's cranes and hydraulics, would be a monumental engineering challenge. For a society without the wheel or iron, it seems to border on the supernatural. How do you quarry, transport, and position such titanic pieces of stone? Mainstream archaeology offers a familiar toolkit: copper saws and chisels, abrasives like wet sand, and the immense coordinated labor of thousands. The most accepted theory for lifting involves a massive ramp system spiraling around the growing pyramid, up which teams would drag these colossal blocks on wooden sleds. Yet when engineers and stonemasons examine the actual evidence, this explanation begins to strain. The precision of the stonework itself is a testament to something beyond brute force. The original outer casing stones, though mostly stripped away over centuries, were fitted together with joints so incredibly tight that you cannot slip a piece of paper, much less a credit card, between them. This is a level of masonry fit we associate with precision machine tools, not with copper implements and guesswork. The granite inside the pyramid, a material far harder than the copper tools available, shows evidence of drilling and cutting that appears smooth and rapid, not laboriously chipped away. These inconsistencies have led a chorus of alternative thinkers, engineers, and historians to ask difficult questions. Could the builders have employed a lost technology? Some point to curious evidence suggesting methods involving sound or vibration. The idea that specific resonant frequencies might have been used to soften or precisely fracture stone, a concept that, while speculative, speaks to the depth of the mystery. This is the great construction conundrum. The mainstream narrative provides a framework, but it often feels like trying to explain a master watchmaker's work by describing only the hammer in his toolbox. The debate between conventional and alternative theories is not just about tools, it is about recognizing a gap in our understanding of ancient capabilities. This unresolved how forces us to look closer, to move from the grand external scale to the pyramid's most intimate and perfectly crafted interior space, where the mystery of its construction becomes a tangible, breathless reality. The true test of their skill lies not outside but within the silent heart of the pyramid. Deep inside that mountain of limestone, you enter the king's chamber, a space that feels utterly alien to its surroundings. The air grows still and cool. Every surface around you is made of red granite, a stone harder than steel, hauled from quarries in Aswan over 500 miles to the south. The sheer logistics of transporting these monoliths are staggering, but it is their finishing that truly defies belief. Each massive slab, some weighing over 80 tons, is not merely cut. Its surface is polished to a mirror-like sheen. Its corners are perfect 90-degree angles, and its edges are so sharp they could slice paper. To achieve this today, you would need diamond-tipped saws, computer-guided milling machines, and industrial polishing equipment. The official narrative gives the builders copper chisels and abrasive sand. Try polishing a piece of granite to a flawless, glassy finish using only a softer metal and some gritty dust. The result would be a scratched, uneven mess. The perfection we see in the king's chamber suggests a different story, one involving tools or techniques we have yet to discover or fully understand. This room is a vault of precision, a sealed box of impossible craftsmanship, but the mysteries here are more than skin deep. Look at the room's dimensions and the placement of the solitary, empty granite sarcophagus. Researchers have noted that the chamber's proportions, its specific length, width, and height, may have been designed to create a resonant cavity. When specific frequencies are produced inside, the room itself can amplify them, creating a powerful, humming vibration. Was this an acoustic accident or an intentional feature? Some theorists propose this could have been part of a lost technology, perhaps even a form of energy generation or focusing, using the natural piezoelectric properties of the granite itself. Whether you find that plausible or not, the undeniable fact is this: the king's chamber represents the absolute pinnacle of the builder's art. It was the final, most sacred space in the entire monument, and they constructed it with a level of material mastery that seems out of place in history. This forces a pivotal question. If this room was the culmination of their entire, decades-long project, was its purpose merely to house a physical resting place? Or was it designed to accomplish something else entirely, something that required this unbelievable precision? To find clues, we must lift our gaze from the polished stone walls and look upward, through the dark, narrow shafts that point like silent arrows toward the heavens. Those polished granite walls of the king's chamber are not the end of the story, they are merely the stage. Look up, and you will find the pyramid's true purpose written not in stone but in light. High on the northern and southern walls of both the king's and queen's chambers, narrow, square shafts, each no wider than a dinner plate, climb at precise angles through 200 feet of solid masonry until they break open to the sky. These are not air vents as was once casually assumed. They are meticulously engineered sightlines, celestial windows carved through a mountain. The southern shaft from the queen's chamber, for example, was not pointed at random stars. At the time of the pyramid's completion, around 2400 BC, it aimed directly at the moment Sirius, the brightest star in our night sky, reached its highest point. In ancient Egyptian cosmology, Sirius was the star of Isis, the goddess of rebirth and the cosmic mother. Its annual heliacal rising just before dawn heralded the flooding of the Nile and the promise of new life. To have this star's light, at its most potent moment, channeled down a perfect stone tube into the heart of the pyramid is an act of profound symbolic intention. It connects the earthly structure to a divine, cyclical promise of renewal, but the alignments go deeper than single stars. The original descending passage, the one used as the entrance, was aligned so precisely that on the spring equinox, the setting sun would send a beam of light racing down its entire length, illuminating the subterranean passage in a dramatic display of solar alignment. This was not a one-time spectacle. It was a built-in calendar marking the balance of day and night with stone and shadow. Even more compelling are the shafts from the king's chamber. The northern one targets the circumpolar stars, the so-called imperishable ones that never set, associated with eternal life. The southern one pointed toward Orion's belt, which was linked to Osiris, the god of the afterlife. These alignments were not arbitrary decorations. They were a functional, three-dimensional star map, permanently fixed in limestone and granite. This reveals a staggering layer of foresight. The Earth's axis slowly wobbles over a cycle of 26,000 years, a phenomenon called the precession of the equinoxes. Because of this wobble, the stars targeted by these shafts have drifted over the millennia. Alpha Draconis was the pole star then, not Polaris as it is today. The builders did not just align the pyramid to the sky of their own time. They built a monument whose relationships with the cosmos were designed to change, to track this grand celestial clock. They encoded time itself into the architecture, planning for a dialogue with the heavens that would unfold across scores of human generations. This transforms the pyramid from a static tomb into a dynamic instrument, an observatory in stone meant to witness the slow dance of the universe. When you combine this with the mathematical encoding of the Earth's dimensions and the precessional number 43,200 found in its proportions, a unified picture emerges. The Great Pyramid stands as a geodetic marker of our planet, a chronological recorder of celestial time, and a temple aligning earthly power with cosmic order. It is a single, unified theory of the ancient world, carved in stone for the ages. This alignment with the shifting stars points toward an even more ambitious form of timekeeping. The number 43,200 found in the pyramid's relationship to the Earth is not just a scaling factor. In certain alternative theories, it emerges again as a direct measure of one of the universe's grandest clocks. This involves a specific and controversial unit of measurement, the so-called pyramid inch. Proponents of this idea, like the 19th century astronomer Charles Piazzi Smythe, noted that if you take the length of the pyramid's base in these hypothetical inches and perform certain geometric calculations involving its diagonals, the resulting sum closely approximates 25,820. That number is significant as it represents a very close estimate for the number of years in one complete cycle of the Earth's axial precession, that slow 26,000-year wobble that gradually changes our pole star. From this perspective, the pyramid is not merely aligned to the stars of its era. It contains a built-in record of the full celestial cycle itself. Mainstream archaeology firmly rejects the pyramid inch as a valid, intentional unit, viewing it as an example of cherry-picking numbers to force a desired result. They argue that with a structure as numerically rich as the Great Pyramid, you can find almost any number you look for if you try enough combinations. This is a vital and necessary critique, a guard against seeing patterns where none exist. Yet, the persistence of these precise astronomical correlations within fringe literature raises a haunting question that transcends the debate over inches. What if the monument's true function was not just as a tomb, but as a kind of stone archive? The idea transforms it from a sepulchre into a potential calculator or data repository, designed to preserve critical knowledge of cosmic cycles across ages, perhaps even across civilizations. If the architects were sophisticated enough to intend this, to encode the precession of the equinoxes into the very bedrock of their greatest creation, then what other layers of information might be locked within its geometry? Could its angles and chambers hold encoded references to the speed of light, to planetary orbits, or to other fundamental constants of physics that we assume are modern discoveries? This line of thinking leads us to the very edge of historical understanding, where solid archaeology meets profound speculation, and where we must confront the ultimate purpose behind such an obsessive, multi-generational project. The pyramid's potential as a celestial clock leads to a correlation so precise it feels almost like a message. When you take the exact geographic latitude of the Great Pyramid, 29.9792458 degrees north, and remove the decimal point, you get the number 299792458. This is the speed of light in a vacuum measured in meters per second. Skeptics are quick to point out the obvious: this must be a coincidence. The meter itself was not defined until the late 18th century, and our exact measurement of light speed is a triumph of 20th century physics. The ancient Egyptians used cubits, not meters, and had no known concept of light traveling at a finite, constant speed across the vast emptiness of space. From a purely historical perspective, the match seems like a beautiful but meaningless accident of numbers. Yet, for those captivated by the pyramid's other mathematical secrets, this coincidence feels different. It is too exact, too clean to dismiss entirely as random noise. It fuels a profound and tantalizing question. What if the pyramid's location was not just chosen for stable bedrock or symbolic alignment, but was itself a piece of coded data? Could its architects have possessed a unit of measurement that, by sheer happenstance, translates almost perfectly into our modern meter, and then deliberately placed their monument on a line of latitude that would one day correspond to one of the universe's fundamental constants? While mainstream scholarship finds this implausible, the numerical echo is undeniable. It acts as a modern-day Rorschach test, revealing less about the pyramid's builders and more about our own desire to find order and intention in the ancient world. This single coordinate transforms the structure from a relic of the past into an active participant in a modern scientific conversation. It creates a bridge across 45 centuries where a number carved into the earth by an unknown hand resonates with a number discovered in our laboratories. Whether designed or destined, this correlation forces a broader view. It asks us to stop looking at the Great Pyramid as an isolated wonder and instead see it as the central piece in a vast, intentional complex. That single coordinate points our attention skyward, but to see the full picture, you must take a step back, a giant step, leave the polished chamber, walk out into the desert sun, and climb the plateau until all three great pyramids of Giza are in view. From this vantage, the scale of the ambition becomes truly clear. You are not looking at three separate tombs built by successive kings, Khufu, Coffer, and Menkaure. You are looking at a single, coordinated master plan etched across the landscape. The placement of these monuments is not random. Their relative sizes and their precise positions on the ground form a pattern that is hauntingly familiar. They mirror with deliberate accuracy the three bright stars that form the belt of the constellation Orion. This is the core of the Orion correlation theory, popularized by researcher Robert Baffles. He proposed that the entire Giza necropolis was designed as a terrestrial map of the heavens, a sacred reflection of Osiris's constellation in the eternal stone of the earth. The correlation is strikingly precise. The two larger pyramids, those of Khufu and Coffer, align diagonally, just as the two brighter stars in Orion's belt do. The third, slightly offset pyramid of Menkaure mirrors the third, fainter star. Even the bend in the arrangement of the three stars is reproduced in the slight angle of the third pyramid's position. But the mapping goes deeper. The theory suggests that the pyramids do not correspond to the position of Orion's belt in 2500 BC when they were built, but to its position much earlier, around 10,500 BC. This implies the layout was based on a celestial blueprint from a far more ancient time, a snapshot of the sky preserved in myth and then finally realized in limestone millennia later. The logistical implication of this is staggering. It means the surveyors for Khufu, the first builder, did not just stake out a plot for his pyramid. They laid down a grand geometric plan spanning miles, marking the future sites for monuments that would be completed by his son and grandson, ensuring the entire complex would lock together as a unified celestial map generations later. This requires a level of centralized, long-term vision that transcends any single pharaoh's ego. It speaks of a cultural project, a sacred duty to anchor a piece of the cosmos to the earth, driven by a mythology that saw the pharaoh's soul traveling to join Osiris in those very stars. Whether you accept the specific 10,000 BC date or not, the deliberate terrestrial mirroring of Orion's belt is a compelling architectural fact. It transforms Giza from a collection of impressive graves into a single, monumental sentence written in geometry and stone, a sentence whose subject is humanity's eternal desire to find our place in the vast, turning night. This profound silence inside the pyramid is its most telling feature. Walk the length of the Grand Gallery, stand in the austere king's chamber, run your hand along the seamless granite walls, and you will find not a single carved image, not one line of sacred text. For a civilization that documented every aspect of life, death, and divinity on temple walls and tomb ceilings, this complete absence of inscription is a thunderous statement. It means we possess no official manual, no architect's notes scratched onto a clay tablet, no royal decree detailing the purpose of the southern shaft. Every other major monument from ancient Egypt speaks to us through hieroglyphs, telling us who built it and for which god. The Great Pyramid only shows us in mute, majestic perfection what was built. This void turns every investigator into a detective at a 4,500-year-old crime scene, where the only clues are the angles of the stones and the alignments to the stars. All our theories about ramps, work crews, and celestial targets are educated reconstructions, attempts to reverse engineer a process whose masters left no written testimony. This intentional silence suggests something crucial, that the pyramid's primary language was never meant to be words. Its message is encoded in geometry, in the precise slope of a passageway, in the exact dimensions of a chamber. It communicates through the universal constants of mathematics and astronomy, a code that transcends any single spoken language or era. To crack this code, we cannot rely on scrolls that may have turned to dust. We must turn to the tools of our own age, scanning the silent stone with the most advanced senses we possess. The silence of the stones is finally meeting the hum of modern machines. To decode a structure built with such impossible precision, we must now measure it with tools that match its ambition. Teams of engineers and archaeologists are no longer just studying the Great Pyramid. They are conducting a high-resolution conversation with it, using laser scanners that map every surface, photogrammetry that builds perfect digital twins, and ground-penetrating radar that peers deep into its hidden heart. This is not mere curiosity, it is a technological necessity. Our eyes can see the grand shape, but they cannot perceive the microscopic intentions locked within the masonry. These scans reveal the truth in numbers, confirming the almost supernatural flatness of the 13-acre foundation with cold, hard data. They show the minute, deliberate deviations in the placement of the few remaining casing stones, subtle adjustments that may have been intentional corrections for optical illusion or seismic settling over millennia. Each new dataset is a revelation. It provides overwhelming support for the sheer scale of the achievement, proving the tolerances are real and not exaggerated. Yet, this same data often dismantles our comfortable assumptions. A laser scan might show a chamber wall that is not quite plumb, or a passageway with a barely perceptible curve, details that spark fierce debate. Was this a construction error, or a designed feature for a purpose we have yet to comprehend? Our most advanced tools are finally catching up to the precision we are trying to measure, creating a dialogue across 45 centuries. We ask a question with a scanner, and the pyramid answers in millimeters and arc seconds. But every clear answer seems to generate two more profound questions. If the scans prove the foundation is level to within an inch, we must then ask not just how they did it, but how they conceived of such a standard of perfection in the first place. This technological investigation inevitably leads us from the stones to the people who moved them. The management of the massive workforce required to execute this plan, housing, feeding, and organizing thousands of individuals for decades, becomes its own staggering puzzle. The precision in the stone implies a parallel precision in human organization, a social engineering feat that may be just as baffling as the geometry itself. The laser scans and astronomical correlations paint a picture of almost divine precision, but they miss the heartbeat of the entire endeavor. Every perfect angle, every aligned stone was first conceived in a human mind, then moved by human hands. The true scale of the mystery is not just in the monument, but in the mobilization of an entire civilization behind it. For over 20 years, a rotating workforce of tens of thousands of individuals lived and breathed this single project. This was not a haphazard gathering of laborers. It was the ancient world's most complex and enduring logistical operation. Until recently, the popular imagination saw this workforce as masses of enslaved people driven by the lash, a grim narrative drawn more from biblical epics than archaeological evidence. Then the ground at Giza began to tell a different story. Excavations led by figures like Dr. Mark Lehner uncovered the buried remains of the workers' settlements, and these findings revolutionized our understanding. They revealed not slave pits but organized, permanent towns with barracks, bakeries large enough to feed thousands, infirmaries showing evidence of medical care like set bones, and even facilities for brewing beer. This was a supported, structured community. The workers were likely skilled artisans and seasonal laborers, recruited from villages across Egypt, performing what was likely seen as a national duty, a sacred service to the god-king that would grant them status and a share in the eternal legacy. This changes everything. It means the pyramid's perfection is not merely a triumph of engineering, but a monumental achievement in social organization. Think of the administrative genius required, coordinating the quarries at Tura for fine limestone, at Aswan for granite, and local sites for the core blocks. Managing a constant river-based supply chain bringing food, tools, and materials from across the kingdom. Scheduling the workforce in rotating shifts, likely 3 months on, then time off, to maintain morale and physical health across decades. They had to solve problems of sanitation for a small city, of dispute resolution, of payroll in the form of bread, beer, and probably other goods. This was a bureaucracy of breathtaking efficiency, a soft technology of management and logistics that operated on a scale unmatched until the modern industrial era. The chief engineer did not just need to know mathematics and astronomy. He needed to be a master administrator, a quartermaster, and a leader of people. This human dimension completes the picture of the pyramid's genius. It shows that the mystery is holistic. The precision in the stone is a direct reflection of the precision in the planning, the coordination, and the communal will that made it possible. It was a symphony of effort, where the surveyor aligning a star shaft was as vital as the baker fueling the mason, and the scribe tallying copper chisels was as crucial as the overseer setting the final casing stone. When we stand in awe of the Great Pyramid today, we are not just admiring ancient engineering, we are witnessing the frozen potential of human collaboration, a testament to what can be achieved when thousands work with a single, transcendent purpose across generations. This realization shifts the final, lingering question from a technical how to a profound why. What belief system, what vision of the cosmos and humanity's place within it, could possibly justify and sustain such an all-consuming, civilization-defining effort for so long? That human symphony of effort raises a profound question of legacy. While the Great Pyramid stands as the ultimate expression of Fourth Dynasty power, its silent companion on the plateau whispers of a much deeper past. To understand the full scope of the mystery, we must turn our gaze from the geometric perfection of Khufu's monument to the weathered, enigmatic face of the Great Sphinx. Carved from the living bedrock, this colossal statue has long been dated to the reign of Coffer, Khufu's successor, around 2500 BC. Its body shows the unmistakable marks of time, but according to a controversial geological analysis, those marks tell a story mainstream history does not accept. In the early 1990s, geologist Robert Schoch of Boston University examined the Sphinx not as an archaeologist, but as a scientist reading the stone itself. He focused on the deep, vertical fissures and undulating, channel-like patterns etched into the limestone walls of the Sphinx enclosure. To his trained eye, these were not the effects of wind and sand, the primary forces in the arid Egyptian climate for the last 5,000 years. Instead, he argued they were classic textbook examples of precipitation-induced water erosion. This kind of heavy, prolonged rainfall weathering requires a very different climate, one that was last present in that region not 4,500 years ago, but much earlier, potentially between 7,000 and 9,000 years before the present, during what's known as the Neolithic subpluvial, a much wetter period in North Africa. If Schoch's interpretation is correct, the core body of the Sphinx could be millennia older than the pyramids themselves. This hypothesis, known as the water erosion theory, sends seismic waves through the conventional timeline. It suggests the Giza plateau was already a sacred or significant site long before the Fourth Dynasty pharaohs arrived. The implications are staggering. It would mean that Coffer, rather than creating the Sphinx from scratch, might have been restoring, recarving, or adopting a monument that was already ancient and eroded in his own time. His work would have been one of renovation, not creation, perhaps recarving the head into his own likeness while clearing the sand from a body whose origins were already lost to legend. This idea transforms our view of the pyramid builders from brilliant originators into brilliant inheritors. It proposes they were working within a tradition, building upon a site already charged with ancient meaning, and perhaps even guided by a legacy of astronomical and geometric knowledge passed down from a forgotten epoch. The precision of the Great Pyramid, then, might not be a sudden, isolated flash of genius, but the pinnacle of a technological and spiritual tradition with roots stretching back into a foggy, pre-literate past. Mainstream Egyptology firmly rejects Scott's conclusions, countering that the erosion could be from wind, from the effects of groundwater, or from the runoff of rare but torrential rainstorms even in a dry climate. They point to the lack of any archaeological evidence, like tools or settlements, from such an early period at the site. The debate is heated and ongoing, a classic clash between hard geological data and the established framework of archaeological evidence. Yet, even if one dismisses the specific dating, the theory forces a valuable perspective shift. It asks us to consider the Giza complex not as three pyramids and a Sphinx built over 3 generations, but as a single, evolving sacred landscape whose full story we are still piecing together. The Sphinx, with its riddling gaze, challenges the neat edges of our history books and suggests that the story of human achievement on that plateau is far longer and far more layered than we have dared to suppose. The Sphinx's silent challenge echoes in the very stones of the pyramid it guards. If this was not merely a tomb, then what was its true function? A growing number of researchers, engineers like Christopher Dunn, propose an answer that sounds like science fiction. They suggest the Great Pyramid was not a monument of death, but a sophisticated machine, a device designed to generate, harness, or transform energy. This radical idea moves the debate from archaeology into the realm of applied physics. The evidence they cite is not found in scrolls, but in the physical properties of the materials and the precise geometry of the chambers. Take the granite used throughout the king's chamber. Granite is not just a hard stone, it contains a high percentage of quartz crystals. Quartz is piezoelectric, meaning it generates a small electrical charge when subjected to mechanical stress or vibration. Now, imagine that entire chamber with its tons of precisely fitted granite, acting as a massive resonator. If the pyramid could be made to vibrate at its natural frequency, perhaps by the wind rushing through its shafts or even by seismic energy from the earth, the theory suggests the quartz within the granite could have produced a measurable electrical field. This is not magic, it is a principle of materials science, though the scale proposed is monumental. Supporters of this view point to another curious clue, the so-called air shafts. If their purpose was simply ventilation for workers, why would they be sealed from the inside? And more tellingly, why is there a complete absence of soot or smoke residue on their walls? This suggests they were never used for torches or fires. Instead, they might have been waveguides, channels designed to direct specific vibrations or even microwave energy into the heart of the structure. Experiments using sound generators inside the Queen's Chamber and the Grand Gallery have shown that these spaces can indeed resonate at specific, powerful frequencies. The entire structure begins to hum, a giant stone bell waiting to be struck. While mainstream archaeology dismisses these ideas as speculative and points out the total lack of any electrical artifacts or wiring, the theories perform a vital service. They force us to abandon our modern prejudice that advanced technology must look like our own with wires and gears. It challenges us to ask, what if a civilization mastered a technology of resonance and harmonic energy, using the Earth itself as a component? To even entertain the possibility is to revolutionize our view of ancient prowess. It transforms the pyramid from a silent tomb into a potential engine, a device humming with a purpose we are only beginning to perceive. And if the pyramid was such an engine, what fuel was it meant to run on? The answer may lie not in the stone, but in the empty space above it, in a force the builders observed every day of their lives. At the very center of that silent, resonant chamber lies its most perplexing artifact. It is a massive box of red granite, often called the Coffer, and it holds a presence that is both solid and deeply mysterious. This is not a container in the traditional sense, for no lid was ever found with it, and no human remains or burial goods have ever been discovered inside. It sits there, empty, a perfect geometric puzzle carved from a single, unimaginably hard block. Its dimensions are the first clue that something unusual is at work. The interior volume of this box, the space inside it, has been calculated to hold exactly 1/2 of the exterior volume. This precise 1:2 ratio is a fundamental geometric relationship, suggesting its proportions were carefully designed, not casually hewn. Furthermore, when you take the exterior dimensions and perform certain calculations, the figures resonate with the same mathematical constants, like pi, that are found in the pyramid's larger design. It is as if this box is a microcosm of the entire structure, a condensed echo of its hidden code, but the practical mystery is just as compelling. The coffer is enormous, weighing an estimated 70 tons. The doorway into the king's chamber and the ascending passages leading to it are simply too narrow for this monolith to have been brought in after the chamber was completed. This means the chamber itself had to be constructed around the coffer. The giant granite blocks forming the walls and the colossal ceiling beams were painstakingly maneuvered into place with this 70-ton obstacle already sitting in the center of the room. This turns conventional logic on its head. Instead of building a room and then furnishing it, the builders placed the central, most enigmatic object first, and then erected the most precise masonry in the world around it. This sequence implies the coffer was not an afterthought or mere furniture. It was the focal point, the very reason for the chamber's existence. The craftsmanship only deepens the enigma. Hollowing out a block of granite to create a box with perfectly straight sides, flat bottom, and incredibly sharp internal 90-degree corners is a feat that would challenge modern diamond-tipped tools. Doing it with copper drills and abrasive sand seems almost fantastical. The surfaces inside are smooth, the corners crisp, a testament to a technique we can scarcely replicate today. And then there is the final, telling deviation. Its shape and size do not match any other known royal sarcophagus from ancient Egypt. Those later sarcophagi have distinct styles, inscriptions, and proportions. This box is unique, a solitary, unadorned form that follows its own silent rules. So if it was not intended as a coffin, what was its purpose? Within the framework of the pyramid as a machine, some researchers propose it could have been a resonant chamber, a key component designed to vibrate in harmony with the room itself, perhaps even filled with a specific substance to alter its acoustic or energetic properties. Others see it as a purely symbolic representation, a geometric ideal made physical. Whatever the truth, the coffer stands as the ultimate embodiment of the pyramid's mystery. It is a masterpiece of unknown function, a centerpiece around which a mountain of stone was meticulously arranged, asking us with every silent, polished inch, what was this all truly? That empty granite coffer at the heart of the pyramid is a question carved in stone. To find an answer, we must step back from our modern obsession with engineering and physics and into the worldview of the people who conceived this place. For them, the drive for mathematical perfection was not a technical challenge to be overcome. It was a spiritual necessity to be fulfilled. In ancient Egyptian cosmology, the pyramid's very shape was a sacred symbol. It represented the Benben, the primordial mound of earth that first emerged from the waters of chaos at the moment of creation. It also mirrored the descending rays of the sun god Ra, a stone pathway for the pharaoh's soul to ascend to join the eternal stars. This was not just architecture, it was a diagram of their universe. The obsessive precision we measure with lasers today was for them the only way to build such a diagram. They were not trying to impress future archaeologists with their tolerances. They were attempting to create a perfect, eternal model of cosmic order, what they called Mat. Mat was the fundamental principle of truth, balance, and harmony that held the universe together. It was the opposite of chaos and disorder. To construct the king's eternal home with anything less than perfect alignment, flawless geometry, and exact proportions would have been to build chaos into its very foundation, dooming the project to spiritual failure. Every inch of that 13-acre base had to be level because the primordial mound was stable. Every side had to point to true north because the cosmos was ordered. The shafts had to align with specific stars because the soul's journey was a precise celestial navigation. The mathematics, then, were a form of prayer, a language used to speak to the divine in the only terms they believed the gods would understand, the language of perfect, unchanging law. This perspective transforms our understanding of the workforce. The thousands of laborers were not just building a tomb, they were participating in a ritual act of cosmic maintenance, aligning the human realm with the divine through collective, sacred effort. The precision was theological. It was an act of faith made visible, a bridge between the earthly and the eternal carved from 2 million blocks of limestone. When we stand baffled by the how, we must also listen for the why, echoing from a culture that saw the universe as a grand, intricate machine of harmony, and believed that humanity's highest duty was to reflect that harmony back in everything they created. This spiritual imperative may be the most powerful engine of all, the one that fueled a civilization to move mountains for a vision that would outlast the stars themselves. That spiritual engine of harmony created a monument that would itself become an engine for human curiosity. The precise mathematics of the Great Pyramid have not only baffled modern engineers, they have captivated some of history's greatest scientific minds for centuries. This long and often eccentric tradition is known as Pyramidology, the study of the pyramid's dimensions in search of hidden knowledge. Its most famous early practitioner was none other than Sir Isaac Newton. In the late 1600s, while formulating his laws of motion and universal gravitation, Newton was also deeply obsessed with the Great Pyramid. He was not looking for alien architects or energy machines. He was searching for something he believed was just as revolutionary, the cubit. Newton was convinced that the pyramid's architects had used a perfect, divinely inspired unit of measurement, one that could unlock a universal standard of length. He pored over every available measurement of the structure, attempting to reverse engineer this sacred cubit, believing it might even help him understand the exact dimensions of the biblical Temple of Solomon. While his quest did not yield the cosmic constant he hoped for, it stands as a powerful testament. Here was the architect of modern physics, humbled and intrigued by the precision of an ancient stone puzzle, recognizing in its geometry a sophistication that demanded serious scholarly attention. This pattern would repeat for generations. Throughout the 1800s and 1900s, pyramidologists, armed with increasingly accurate surveys, would propose elaborate theories, finding prophecies, timelines, and complex numerological codes within the pyramid's angles. While much of this work drifted into the realm of fringe speculation, it had an unintended and profoundly positive consequence. It drove the demand for ever more precise archaeological surveys. The desire to prove or disprove these wild theories funded expeditions and spurred the development of more accurate measuring tools, indirectly advancing the very science of archaeology. The pyramid's mystery acted as a magnet, pulling scientific rigor toward it in an effort to separate fact from fantasy. This legacy of measured curiosity did not end with the tape measure. Today, the intellectual seeds planted by pyramidology have grown into respected interdisciplinary fields. Archaeoastronomy, the study of how ancient cultures understood and used celestial phenomena, was born from questions first posed by those staring at the pyramid star shaft. Engineers and architects now engage in a form of reverse engineering called biomimicry, studying the pyramid not for secret messages, but for brilliant, practical solutions. They analyze its natural passive ventilation system, wondering how its internal air shafts helped regulate temperature and humidity without any moving parts. They marvel at its seismic stability, its ability to distribute weight and withstand earthquakes over millennia, principles that could inform more resilient modern structures. In this light, the Great Pyramid's greatest gift is not a single answer but a perpetual question. It serves as an intellectual catalyst, a stone muse that has for centuries pushed mathematicians, astronomers, historians, and engineers to look deeper, measure more carefully, and think more boldly. Its true treasure is the unending curiosity it ignites, a flame that continues to illuminate new paths of discovery across the disciplines. This relentless curiosity, however, demands a crucial moment of intellectual honesty. For every awe-inspiring correlation, a skeptical voice rightly asks, are we seeing a master plan, or are we simply painting targets around bullet holes? This is the heart of a critical debate that separates compelling mystery from unsubstantiated myth. Statisticians have a name for this common pitfall of pattern seeking. They call it the Texas Sharpshooter fallacy. Imagine someone firing a shotgun at the side of a barn from 100 yards away. Afterward, they walk up, find the tightest cluster of pellet holes, and paint a bullseye around it, proclaiming themselves a marksman. The flaw is obvious. The target was drawn after the fact based on the random outcome. When we look at the Great Pyramid with our modern knowledge of pi, the speed of light, and the Earth's circumference, we risk doing the same thing. We are drawing the target of our own scientific understanding around a structure built with a completely different cultural and intellectual toolkit. The pyramid is a numerical treasure trove, its base perimeter, height, angles, and chamber dimensions offering a vast array of numbers. If you try enough combinations, multiplying by this, dividing by that, converting cubits to inches or meters, you can inevitably produce figures that resemble important modern constants. The question is not whether you can find these numbers, but whether their presence is statistically significant and, more importantly, historically plausible. Did the builders know about the meter, a unit defined in the late 18th century? Almost certainly not. Did they conceptualize the speed of light as a finite constant measured in meters per second? There is no evidence to suggest it. A rigorous analysis must therefore filter these correlations through the lens of what we know the ancient Egyptians actually understood. Their mathematical papyri show practical arithmetic and geometry for administering land and building projects. They used a value for pi approximated as the ratio of 256 to 81, which is about 3.16, close but not the transcendental constant we know. This was a useful figure for calculating areas of circles, not an abstract number encoded for its own sake. When we find pi in the pyramid's perimeter to height ratio, it might reflect a practical building technique, like using a rolling drum measure, rather than a conscious embedding of a mathematical absolute. Applying this critical lens is not about dismissing the pyramid's genius. It is about refining our understanding of where that genius truly lies. It shifts the wonder from potentially spurious numerical echoes to the tangible, undeniable achievements, the level foundation, the celestial alignment, the staggering logistics, the flawless masonry. These are facts that require no retroactive number crunching to appreciate. They stand on their own, testaments to a civilization that operated at the peak of human capability for its time. This balanced perspective ensures our fascination is rooted not in wishful thinking, but in the solid, awe-inspiring ground of credible evidence. It allows us to marvel at the real miracle, the one etched in stone under the desert sun, without needing to cloak it in mysteries it may never have intended to hold. That critical lens of skepticism clears the air, allowing us to see the pyramid's original, breathtaking reality with fresh eyes. We have been discussing the bare, stepped core, the skeleton of the monument. But in its prime, the Great Pyramid wore a skin of light. Its entire exterior was once sheathed in an estimated 144,000 highly polished, gleaming white casing stones, quarried from the fine limestone beds across the Nile at Tura. These were not simple blocks, they were masterpieces of optical and geometric engineering. Each one was cut with such extraordinary exactitude that when fitted together on the pyramid's sloping faces, the seams between them were less than a millimeter wide, finer than the edge of a coin. This created a surface so impossibly smooth, so perfectly planar, that from a distance the entire structure would have appeared as a single, seamless, geometric form rising from the desert. The visual effect was calculated to be staggering. Ancient texts called the pyramid Ikhit, a word meaning glorious light. At sunrise and sunset, this polished white shell would have acted like a colossal mirror, catching the sun's rays and blazing with such intensity that it could likely be seen for dozens of miles, a man-made mountain of captured sunlight. This was not just a pretty finish, it was the ultimate statement of the builder's intent. The pyramid was designed to be experienced. That flawless, reflective skin transformed an abstract geometric model into a visceral, awe-inspiring spectacle, a beacon of order and power that dominated both the landscape and the imagination. Today, that glorious shell is almost entirely gone. Centuries of earthquakes and, most notably, systematic removal for medieval construction in Cairo stripped the pyramid down to its rough core. Yet at the very base, tucked beneath the accumulated sand and rubble, a small cluster of these original casing stones remains in place. To see them is to witness a ghost of that former perfection. Their surfaces, though now weathered, still show the precise beveled edges and the faint, whisper-thin lines where they met their neighbors. They are a direct, tactile link to the pinnacle of the builder's finish work, proving that the microscopic tolerances we infer were not theoretical, they were real. This lost exterior adds a profound new dimension to our understanding. The pyramid was a multi-sensory experience. Its mathematical precision was hidden within, a secret code of knowledge. But its visual perfection was an external, public declaration. It meant that every observer, from the farthest peasant in the fields to the visiting dignitary, would have understood on an instinctual level that they were witnessing something beyond human scale, something divine. The glorious light was the final, brilliant argument of the pyramid's purpose, proving that its architects sought mastery not only over stone and star, but over the very phenomenon of light itself. Yet the pyramid's secrets are not confined to its grandest rooms. Tucked lower within the colossal structure lies the Queen's Chamber, a space of quieter, more intimate mystery. Unlike the soaring granite of the king's space above, this chamber is lined with smooth limestone, its ceiling rising to a graceful peaked gable. Its name is a modern misnomer, as Egyptologists now believe it was never intended for a queen's resting place. Its true purpose remains one of the structure's most persistent puzzles, and the clues are etched into its very walls. On the north and south sides of the chamber, two narrow, square shafts, each barely 8 inches wide, begin a slow, sloping ascent into the darkness. These are not like the open, star-pointing shafts of the king's chamber. For centuries, they were a complete enigma because they simply stopped, sealed deep within the masonry, leading nowhere. They were discovered in 1872 by the British engineer Wayneman Dixon, who, curious about small cracks in the walls, chipped away to find these perfectly carved tunnels. Their sealed ends immediately ruled out simple ventilation. So why would the builders go to the immense trouble of carving these precise, miniature corridors only to deliberately block them before they reached the outside world? The leading theory is a beautiful and spiritual one, that they were symbolic pathways for the pharaoh's soul, known as the Ka, allowing it to travel symbolically toward the northern and southern stars. Yet, their physical construction suggests something more tangible than pure symbolism. The precision of their boring through hundreds of feet of stone mirrors the exacting standards found everywhere else, implying a functional requirement, not just an artistic gesture. This chamber, often overlooked, forces a critical realization. The pyramid's design precision extends far beyond the spaces we can walk through. It weaves through the very heart of the stone itself, in channels too small for any human to ever enter, created with a purpose we can only guess at. The mystery of these sealed shafts would deepen dramatically more than a century after their discovery, thanks to a machine small enough to travel where no person ever could. The silent perfection of those sealed shafts could only be understood by the hands that carved them. We have spent so much time marveling at the geometry of the stone that we risk forgetting the geometry of the mind behind it. This was not the work of an anonymous, unskilled mass. The true secret of the Great Pyramid lies in the technical knowledge of its workforce, a vast collective of specialized artisans who turned abstract design into enduring reality. Within that bustling 20-year project, there existed a hidden hierarchy of skill. Think of the masons who could dress a limestone block so perfectly that it fit against its neighbor without mortar, creating a seam thinner than a blade of grass. Consider the surveyors who, using nothing more than sighting rods and lengths of knotted cord, could maintain a perfectly square corner across a distance of 750 feet, an area larger than 10 city blocks. Envision the astronomers who, night after night, tracked the slow drift of stars to calibrate those narrow shafts with celestial precision. These were not laborers in the simple sense. They were engineers, geometers, and craftsmen of the highest order. Their tools were elegantly simple, but their application was brilliantly sophisticated. To level the 13-acre foundation, they likely dug a grid of shallow trenches across the bedrock, filled them with water, and used the immutable law that water seeks its own level. By marking a consistent height on the trench walls, they could transfer a perfectly flat plane across the entire chaotic landscape, a method still used in principle by builders today. For alignment, they used the plumb bob and the sighting rod, tools that leverage gravity and line of sight to create true verticals and horizontals. Their measuring cords, standardized to the royal cubit, were their blueprints, stretched taut across the desert to translate the architect's vision from papyrus to plateau. This was applied intelligence on a civilization-wide scale. It was empirical knowledge, refined and passed down through generations of builders, temple architects, and irrigation engineers. The Pyramid Project did not invent this knowledge, it concentrated it, gathering the finest practical minds from across Egypt and focusing them on a single, transcendent goal. Their legacy is the monument itself, a proof that human ingenuity, when systematically organized and directed by a unified vision, can achieve what later ages, with all their advanced technology, still look upon and deem nearly impossible. The stones are not just a testament to what they built, but to how they thought, solving immense physical problems with clarity, patience, and a profound understanding of the natural world. The geometry of the Great Pyramid does not end at the edge of the Giza Plateau. Its precise coordinates have led some to draw lines across the entire globe, connecting it to other ancient wonders in a pattern that suggests a map written in stone. Researchers exploring this fringe of archaeology have noted that the latitude of the Great Pyramid, that same line that echoes the speed of light, forms a curious relationship with other key sites. If you take the distance from the pyramid to the ancient temple complex of Angkor Wat in Cambodia, for example, the great circle arc between them represents a specific fraction of the Earth's circumference. Similar claims are made about its alignment with Stonehenge in England and the Temple Mount in Jerusalem, proposing a global network of sites placed with intentional geodetic knowledge. The theories often rely on great circle navigation, the shortest path between 2 points on a sphere, suggesting the builders understood the Earth as a globe and could calculate positions across vast, uncharted distances. This idea of a prehistoric global grid is without question one of the most speculative areas of pyramid research. Mainstream scholars dismiss it as a classic case of the Texas Sharpshooter fallacy on a planetary scale. With thousands of significant ancient sites dotting the continents, they argue, you can always find some that align by chance if you look hard enough and are flexible with your measurements. The selective use of sites, ignoring the many that do not fit the pattern, is a critical flaw. There is no archaeological evidence, no shared artifacts or written records, to suggest a globe-spanning civilization in deep antiquity capable of such coordinated surveying. Yet the persistence of these claims is itself a fascinating phenomenon. It reveals something profound about the pyramid's role in the human imagination. It has become the ultimate anchor point, the fixed star in our search for a lost, unified past. Whether the alignments are real or imagined, they speak to a deep-seated desire to see our ancient ancestors not as isolated cultures, but as participants in a shared, sophisticated understanding of the world. The Great Pyramid, in its silent, mathematical perfection, invites this grand speculation. It stands as a central datum, a benchmark of such undeniable precision that it naturally becomes the starting point for any theory seeking a hidden order in history. This pushes the mystery far beyond the sands of Egypt, transforming it from a national monument into a potential keystone in a forgotten global architecture. That silent, polished skin is gone, leaving only the rough core of the question. The Great Pyramid of Giza stands as a permanent question mark carved in desert stone, a testament to a precision that humbles our modern engineering pride. We have traced its lines from the bedrock to the stars, from the geometry of its base to the echoes of celestial cycles within its chambers. We have seen a design philosophy that masterfully intertwined hard mathematics with profound astronomy and deep spirituality, creating not just a tomb but a model of the cosmos itself. Every facet, from that cardinal alignment accurate to a fraction of a degree to the logistical miracle of feeding and housing an army of skilled workers for decades, challenges any simplistic view of the ancient past. It whispers of a civilization that viewed order as a sacred duty and perfection as the only language worthy of addressing the eternal. We may never fully know the intimate thoughts of the chief architect as he gave the final command, or the quiet satisfaction of the mason who set the last casing stone. The motives of the human heart are the one thing not encoded in the limestone, yet the pyramid's enduring mystery serves a purpose far greater than providing definitive answers. It is an engine of perpetual curiosity. It drives exploration, funding scientific scans and archaeological digs. It fuels passionate debate in lecture halls and online forums between staunch traditionalists and bold alternative thinkers. This ongoing conversation is a gift. It reminds us that history is not a closed book with all the answers in the back, but a living, breathing field of discovery that is far deeper and more wonderfully complex than our textbooks often allow. The true legacy of the Great Pyramid may not be in proving what the ancients knew, but in showing us how much we still have to learn. Let this journey inspire you to look at the ancient world with fresh eyes, to question the established narratives, and to marvel at the sheer scope of human potential. We would love to hear your perspective. Share your own thoughts in the comments below. What single aspect of this mathematical marvel, from the sealed shafts to the silent coffer, baffles you the most?